Hello, welcome to Exploring Cloud Platform Tutorials. In today's video, we will see how to configure ELB service with Amazon EC2 instances. What is ELB? Elastic Load Balancing is a service from Amazon Web Services. It automatically distributes incoming application traffic across multiple targets. Here, targets can be any Amazon EC2 instances, EC2 containers, or IP addresses. The goal of this tutorial is to demonstrate the usage of ELB service with two EC2 instances that are installed with a web server, and to demonstrate how to route the traffic between these two instances. That means incoming traffic to the application should distribute using ELB. So let us see from the scratch. For this demonstration, we need the setup. The setup includes one default VPC that comes with the account, one default subnet, let us take it as a public subnet, and two availability zones. And we are going to define this demo using the default security group. The default security group will be having a inbound and outbound rule with all traffic configured, and we will be working with the two Amazon Linux instances. So let us see how to configure ELB using two Amazon Linux EC2 instances where a web server is running. The very first step is to log into the Amazon console. From here, navigate to EC2 from compute section. Here there are two instances already running. We are going to create two more instances for our demonstration. For this, let us launch them by clicking on this launch instance button. So here there are various steps to install an Amazon EC2 instances. Let us install this Amazon Linux AMI. So select the first one, choose the instance type, T2 micro, EVS only, and here let us take default VPC, and the subnet let us take South 1A. This demonstration is basically in Mumbai region. Then click on add storage 8, then take magnetic and add tags name web server -01, configure security group, select new security group, select existing one. Let us take the default one, review and launch, continue with the magnetic storage, launch, choose a new key pair, web server -01, download key pair, which downloads a PEM file. launch instance. The instance is launching, and you can view the instance by clicking on this view instance button. This is web server 01. So let us stop these two servers, which we are not going to use for this demonstration. Stop. Yes. And stop. Yes. Similarly, create another EC2 instance which we call it as web server 02. Launch instance. Again Amazon EC2. And similarly, this second EC2 instances we are going to create in the second availability zone, that is AP South 1B. Add storage, magnetic, add tag, name, sorry, web server 02, configure security group, select the existing one and give inlines, continue with the magnetic one, launch, create a new pair, it is named as web server 02, download key pair, save, launch instance. Using Putigen, convert PEM files into PPK files, load all files 01, click on save private key, yes, PPK. Similarly, the second one, load, save private key, yes, so two PPK files are available. Let us connect to these servers once the instances are ready. So let us check the status of the instances here, and web server 01, this is initializing and this is also initializing. First connect to web server 01 and install a web server called httpd. The commands that we use are here to install the httpd web server. Open the putty, then still it is initializing, and the first web server is ready. From the description tab from the bottom section, take either the public IP address or the DNS name. Let us take the DNS name for web server 01, give it in hostname, then go to SSH, expand the node, from the authorization give the first PPK file, then click on open, click on yes. For the Amazon Linux instance, the login user is EC2 user. Now start installing the web server, which is httpd. Sudo yum install httpd, enter. Proceed with yes. Start the httpd server. Yes, started. always on the HTTP server. Whenever, that means whenever the Linux machine boots up, the service automatically in on mode. Now let us write an index.html file in this HTTPD server. Control C, then in insert mode, let us copy this one. Control C, save, escape, double Q. This is the code, and the code is perfect. Now let us check whether this index.html page is working in first web server or not by taking the URL of the, by taking the IP address or DNS name in a web browser URL. Control C. So this is hello world for first web server. So what we did so far is, in a default VPC, in a single subnet, in one of the availability zones, we have installed a we have configured an EC2 instance, and in that EC2 instance we have installed a web server called as HTTPD. In this HTTPD web server, we have written an HTML file called index.html. That index.html is the starting page where we do the health checks. Health checks, we see a later point of time. So that index.html file, the status of that file we can observe by taking the DNS name or the public IP address in the web server URL. Similarly, do the same steps in web server 02. That means in second web server also install the HTTPD web server and write an index.html file in this location, variable www.html. In the HTML code, let us change the background color of the index.html to differentiate web server 01, web server 02. So what we have to do here, take a new session with the second web server IP address or the DNS name. Here web server 02 is available. Copy this code in the new one, take in the host name. In SSH, in the authentication panel, it was for the second TPK file, that is web server 02. Open, yes, the username is EC2 user. Use the same commands to install HTTPD server. Proceed with yes. Start the service. Service is started, and always run the instance and write an index.html file in insert mode. Take this code now, save this, escape : WQ, first of all. Then check the code using cat command, or you can use the same vi command. Now to test that index.html is working fine or not, take the DNS name of the second web server and give it in the URL of the web browser. Now you see this is web server 01 and this is web server 02. This is second web server. So let us make small changes in the code. This is in insert mode second web server .v2. Second web server. This is second web server and this is the first web server. So our goal is to demonstrate the ELB services with two instances that are installed with a web server. So now we are ready with the two instances and a web server installed in those two EC2 instances. So navigate back to the management console. From the left hand side EC2 dashboard panel, navigate to load balancer. As I said, load balancer is an EC2 service. Load balancing is a EC2 service which automatically distributes incoming application traffic across multiple targets. That means, let me open up architecture diagram, a sample architectural diagram. Here 5. So a user can access this web application using a desktop or using an iPad or mobile or various other client tools. So whenever the topic is used, this ELB service will route the traffic to the available EC2 instance. This is the architecture diagram. This is a sample architecture diagram. So by looking at this architectural diagram, you can understand whenever the topic is used, this ELB service will route the topic to the nearest available EC2 instance. So it checks for the it checks for the health of the EC2 instance. If the health of the EC2 instance is fine, then this ELB service route the traffic to the EC2 instance. So let us see how to configure load balancer to the two EC2 instances that are running this index.html application. So from the EC2 dashboard, go to the load balancers. This is another load balancer which I already using for other applications. So let us start with a new load balancer by clicking on this create load balancer button. Load balancers are three types in Amazon. One is application load balancer, and the next one is network load balancer, and the third one is classic load balancers. The major difference between these load balancers is the application load balancer and network load balancer to route the traffic to a target, whereas this classic load balancer routes the traffic directly to the instances, not to a group or target. So basically this application or network load balancers routes the traffic to a target. We will see what is target here, and we will see what is health check here. So for our demonstration we are sticking with the first one, which is application load balancer. So the popular protocols that we work with application load balancer is HTTP and HTTPS. So click on this create button. Here you can see series of various steps to configure the load balancer. The first one is configure load balancer. The name is, let us give a name like my web ELB, and there are two schemas. One is internet facing and another is internal schema. The difference between these two is internal is specific to the local instances that are running in your internal VPC, whereas internet facing is you can access this over the internet from anywhere, and the IP address type is IPv4. Here you can see the description of the schemas. An internet facing load balancer routes requests from clients over the internet to the targets. An internal load balancer routes requests from clients to targets using private IP addresses. That means private LAN kind of things. Here, for every load balancer, we need to configure a listener. A listener is a process that checks for connection requests using the protocol and port that you are configured. A listener requires a protocol and a port. For HTTP, the default load balancer port could be 80. So you can click on the add listener button. So let us stick with the default one, and the availability zone that we use for this load balancer. Every load balancer, every application load balancer requires a VPC, and this ELB service we are configuring with the two availability zones. Why? Because we launched two instances in two different zones, South A, South D, and tags my, you can give name my ELB. Then the next one, configure security settings. You always read the warning messages here. So as we are not using HTTPS protocol, you can see this message. If you want to use HTTPS, you need to go back to the previous step and configure. You have to configure something else. Click on this configure security groups. Let us take an existing security group, which is the default one. Configure routing. New ELB. Let us give some name. My ELB. My web ELB. Something like this you can give. And here you can see the description of each of the field. Target group. So what is target group here is the load balancer will route requests to the targets in the target group by default. Basically, target group is a collection of instances that we want to route the application traffic. If you have an unused target group in the load balance VPC, you can select it. Otherwise, you can create a new target group for the use with this load balancer. So we are going to create a new target group here. If we have any existing target group, we can take that target group and add instances. So here target type is instances. As I said, the targets could be EC2 instances, containers, and IP addresses. Our demonstration is basically based on EC2 instances. So let us take EC2. The type of the target group is instance, and the port is 80, and the protocol that we are using is HTTP. And health checks, and the path, here the path is index.html from the HTTPD web server that we install individually on both the instances. So advanced health check settings, port is topic port. Again, you can see the description of each field here. So let us stick with the default values in this section. If you want to look at what is healthy threshold, unhealthy threshold, just hold the mouse over here and try to understand that try to understand the use of this particular field by reading the description. Now registering targets. So here you can see there are two sections, register targets and instances. So as our ELB is based on instances, let us select these two instances and add these to the targets. So you have to select these instances and you need to click on this add to register. You can see these two instances is added to the target that we created in previous step. Let's take a review. Load balancer, name schema listeners, security group default one, and routing and targets. Click on create. With this we have created load balancer. So click on close. The status of this my web ELB currently is provisioning, and it will take a few minutes of time to get it into active state. Sorry. Refresh this one. Still it is in provisioning state. Meanwhile we can see some basic properties of this ELB. In the bottom section you can see 4 different kinds of properties available in 4 tabs: description, listeners, monitoring, tags. In the description you can see the basic properties like name, year and DNS name. Schema, type and availability zones, security group, listeners, you can perform certain actions on these listeners. You can add or edit the listener. On a listener you can write rules like if else condition, something like that you can write, but for our demonstration we are not going to see that. In future videos we may look back into this section. Now you can see the status of this ELB is active. listeners. As I clicked on the target group in previous window, now you can see the detailed view of this particular target group. The target group that created along with the ELB is my web ELB, and you can see various properties of this target group. And in the targets you can see the registered targets, that means the registered EC2 instances that are web server 01 and web server 02, which are running both on 80 port number. And the status you can see, this is healthy. If this is unhealthy, you cannot see the ELB is working properly. Health checks, and here what is an health check here? Application load balancer periodically sends requests to its targets to test their statuses. These tests are called as health checks. So here this application load balancer, it periodically sends requests to the EC2 instances. So basically these checkings we call as health checks. So that's all we have to do to configure an ELB. Let us see how to test this ELB over those two EC2 instances. So you can always come back to this section, load balancing section. You can see there are two sections in the load balancing. One is load balancer and another is target groups. So in the load balancer section, our ELB, our load balancer, our application load balancer is my web ELB, and while creating this my web ELB, we also have created target groups, and our target group for this demonstration is my web ELB, which is running on 80 port number with HTTP protocol. So to test the index.html application using this ELB, you need to take the DNS name of this ELB. The DNS name is available in the description properties and here. So take this one and type this DNS name in any of the web browser and click on enter. Now you can see the ELB, the application ELB routed traffic to the second web server. If you refresh this page, it may route to the traffic to the first web server. So just refresh this page. Yeah, you can see the result here. Now the ELB application, ELB service routed the traffic to the first web server. Again, if you click on this refresh button, you can see the ELB is routed to the second web server. So this way you can configure an application ELB service to the EC2 instances where web servers are running. So that's all about ELB. Thank you.